Okay, in lens design, this is second video. So lens design factor of contact lens. So several A's have been identified, including round, knife, or sizzle edges. Another point: the thinner knife, the sizzle edge design appear to give better comfort and sit closer to the bulbar conjunctiva and shows less movement and have less interaction with the lead. Less interaction with the lead. Then do with the round edges. So first thing you have to understand the edge and the shape of the edge. That really matters when we are talking about comfort, because the most important thing edges interact with two things. One is bulbar conjunctiva of above is clear, yes, and another is palpebral conjunctiva of lead. So whenever it interacts with the lead, and it interacts with the lead with a forceful interaction, or it actually it plunge in into the lead, or lead is constantly interact with the upper lid palpebra, upper lid palpebra is interact with the lens edge, then we have that sensation and discomfort. One of the great reason of discomfort is interaction of upper lid palpebra conjunctiva with a contact lens edge. So that's why edge is also very important, not just in a fitting, but as a comfort factor. You have to understand. So picture A, what is it? Well-rounded edge. Yes. Picture B, sharp posterior edge. Even sharp posterior edge is no problem, but the sharp anterior edge is problem, because sharp anterior edge will definitely interact with the lead, basically lead. Yes, upper pulmonary conjunctiva is a part of the lead, and flat edge also create a little bit problem. So that's why it's better the round edge. Yeah. So these two concepts that we have to know, and we have to know later on too, and we have to know this concept by your heart. What is edge lift and what is edge clear? Then later on in terminology video, I'll make sure that I'll try to make sure that what is axial edge lift and what is radial edge lift. For now, I think there is, or I don't know. So let's move. So edge lift and edge clearance. First thing I want to make sure that edge clearance is your responsibility as an optometrist. You will see edge clearance when you put contact lens to the patient's eye. You will see edge clearance, you will judge edge clearance. But at the same time, edge lift is not your thing. It's contact lens company's thing. It's like manufacturer's things. Okay? Edge lift, you order edge lift change. And what you see in the patient's eye is edge clearance. Okay? That's the difference. Very important difference. Without the peripheral gap between the edge of the lens and the cornea, mechanical pressure leads to superior corneal damage. Yes, we don't want this edge goes here in conjunctiva and stick to it. Do we? Definitely we don't want that. If that happened, then there is no tear exchange, or there is indentation, or there is a force. Sometimes if it is too hard, like in heavy scleral lenses, then conjunctiva can be split there. Yes, and especially in pinching of the lens edge. So that's going to be quite dramatically bad. So important for tear exchange, yes, definitely, and enable lens to removal by using lead. So okay, lens removal is not a big factor. We can remove by another technique too, but we don't want contact lens periphery, extreme periphery, to impinge in conjunctiva. Do we? We don't want. So what do you mean by edge clearance? See, I'll first clear make sure edge clearance, then we will move to edge clearance is that gap. Can you see here the gap between the contact lens periphery and the surface? Okay, that's cornea. Yes, cornea. So contact lens edge, extreme edge, and the cornea. That distance is edge clearance. Yes. What is edge lift? So that's now we have to imagine something. Edge lift is when the base curve, this is base curve, this is first curve, yes, when the base curve, you extend base curve, yeah, you extend the base curve and the edge of the contact lens to directly, this, see, this edge lift is taken parallel with the optical axis. That's why it's called, what do you, it's called axial edge lift. Whenever it's parallel with the radius, then we will call radial edge lift. So extreme edge of the contact lens and that dash dash thing, then you extend that BOZR. So the distance between the extreme periphery of the contact lens and the imaginary point where you actually extend that BOZR, that distance is called axial lift, edge lift, sorry, edge lift. But we are measuring edge lift axially, that's why it's axial edge lift. If we are measuring that edge lift in radial fashion, means parallel to the radius, like radius, yes, like the center of the uh, optical center. If optical center passes and then there is this BOZR center, and we try to draw that line towards that center, which is radial edge lift. Now currently in picture is axial edge lift, yes, axial edge lift. So that's the difference. Axial edge lift itself is a point of contact lens manufacturer, but edge clearance you will see in patient's eye. When you put contact lens and fluorescein, you will see edge clearance. Okay, so minimum edge clearance in contact lens, especially uh, corneal contact lens, is 60 to 80 micrometer when the lens is centered and considered to be optimum value. So it's very important, but for corneal lenses, yeah. So I have taken this picture again from Efron. So design of contact lens is important issue. It optimizes the ocular response for individual and purpose to achieve the comfort and safety. Definitely, but comfort and safety, are major responsible for periphery designs. Yeah, edge and periphery, first curve or second back curve, and first front surface curve. These are more responsible for comfort because they are more responsible for fitting issues. It's definitely back optic zone diameter. Definitely. The design of RGB lenses can be more complex than soft contact lens. Yes, the design matters most with a physiologically poorer material and least with better material. See, it doesn't matter if it is physiologically poor or physiologically sorry, decay by T is high or decay by T is low. But if decay by T is low, for example, decay by T is low, we have to rely on tear exchange, isn't it? For oxygen exchange. So that we need good design and good fitting, so that there is a maximum tear exchange, which is 10 to 20% of oxygen brings from that sorry, came from that uh, tear exchange itself. So it's, so that's the concept basically. So that, again we came to societal height, because I have already told you societal height is very 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 important. We can talk about societal height like 50 times, yes. So societal height is basically perpendicular distance from the center posterior portion of contact lens to the diameter of the lens. First, I want you to see contact lens as a one portion, one chord of the circle. It's not circle, it's definitely one chord of the sphere, but for now one chord of the circle. So this is the chord, this diameter, yes, and definitely this is a sagittal depth. We have talked about diameter and the radius of curvature and the relationship of sagittal height, yes. Sagittal height relationship with radius of curvature, relationship with diameter. And we have talked about when diameter is constant, what about changing radius will create change in sagittal height. What about when we take radius of curvature constant and changing diameter will change the sagittal height of that particular contact lens, or maybe just the normal relation. It's not about just contact lens, it's about in any field. Yes, what about the changing radius and keeping diameter constant? What about the keeping radius constant and changing diameter? And what about changing both things, especially in contact lens? The rule of thumb, yes, 0.5 mm increase in BOZT, we have to increase 0.05 mm BOZR to make sure that sagittal height remains same. Yes, that's the rule of thumb. So both are increasing. Yes, BOZD increase, then BOZR should be increased. This is the concept. Okay. So it's important parameter in alternating fit of the contact lens, because more the steeper the depth, higher the sagittal depth, steeper is steep the fitting. Yeah. So lower the sagittal depth, looser the fitting. So alternating the sagittal depth by changing the base curve or diameter or alters the contact lens fit and is specific in mm. So just remember these concepts: constant in diameter, constant radius of curvature, how things changes in sagittal height. This concept will definitely ask in your exam. It's always there. It's always like there, 100% like. So just remember, you will see that MCQs, you will see the um, SAQs questions based on this concept. It's You cannot escape this concept. Okay, this is the most important concept. So I have already shown you that the same diameter, and when we decrease the radius of curvature or when we increase the curvature, because radius of curvature and curvature are opposite thing, then when we increase the curvature or decrease the radius of curvature, sagittal height increases. Yes, we have to keep lens diameter constant. So again, same thing. We kept the lens diameter, sorry, radius of curvature equal the radius of curvature r, but sagittal height 1 is larger than sagittal height 2, then sagittal height 3. Yes. So when we kept the diameter constant, sorry, radius of 1, 2, and 3. So radius of curvature 1 is smaller, and radius of curvature 3 is larger. So that height is exactly opposite. 1 is larger and 3 is smaller. Yeah, we keep diameter constant. So same time we keep diameter constant. So we keep radius of curvature constant, but we increase the diameter. As you increase the diameter, so that the height increases directly proportionally. Yes, we keep r constant. Yes, that's the concept. So here we keep r constant and we increase d. So basically d1, d2 is larger. At the same time, s1, s2 is larger. So this is larger. Yes, it's very simple. So effect of sagittal depth, all factors remains unaltered, especially total diameter of the lens. Then decreasing BOZR will steepens the lens fit basically, and increasing BOZR will loosen the lens fit. What do you mean by increasing the BOZR? It means sagittal height decreases. Yes, whenever sagittal height decreases, what happens? Fitting is loose. Whenever sagittal height increases, fitting is tight. Yes, yes, that's the concept. This is because the step increase and decrease sagittal height respectively. So it's very simple. Whenever sagittal height increases, lens fitting will be tight. Whenever sagittal height decreases, lens fitting will be loose. Finished. So let's talk about sagittal height in a one table. So sagittal height, yes, we know vertical depth of the lens measured in the chord of the diameter. So we have formula. Yes, we know it. If we increase this, increases larger the numerical sag value. How it changes? If fit a clinical effect, so larger the sag, tighter the fit. That's what I am talking about. Okay, larger the fit, tighter the fit. And less, what do you mean tighter fit means? Less lens movement. Yes, and more central clearance. Yes, it's very simple, isn't it? So looser the fit, it's more movement. So how the looser, smaller the sag, looser the fit. That's what I want to know. I want to talk about. So the use of compare the use of use SAC to compare different lens design, even when base curve and the diameter different. So it's very important. You can compare different contact lens using only sagittal height. So lens diameter, total diameter or chord. So what happens here? Increasing diameter, increase sagittal height at all. Yes, for same radius. That's what I. So steepen the base curve. What do you mean by steepen? Smaller radius of curvature will increase the sagittal height, considering diameter is constant. Yes, so that's a very important concept. Okay, so steeper base curve increases the vault and clearance. So definitely it will create tight fitting. So Then, what is ocular sagittal height? Mm, So basically, the measurement of sag of eye or sclera for a given chord. That's very important. Whenever it's important when we try to fit scleral lens. Yeah. So contact lens, if contact lens sag minus sagittal sag, or if ocular sag minus sagittal sag, it must be there. Yeah. Contact lens sag minus sagittal sag should be larger than ocular sag minus sagittal sag. And excessive vault or tight. So basically excessive vault or tight. We want that, but not heavily. So what happens if contact lens sag minus sagittal sag or ocular sag, the bearing and central touch. That's what we don't want. Yes, we don't want that concept. So sometimes we have to compare the ocular sag with the sag of the contact lens too. And what we want is upper condition. It's always there, especially in scleral lens fitting. Okay. So central thickness is another part we have already talked about it. The central thickness goes higher. One of the important thing is whenever central thickness goes higher, so it's better for lens handling. Yes, especially soft contact lens. And whenever some central thickness goes higher, decay by T goes down because we know decay and divided by T. Whenever T goes high, the overall thing goes down. Yes. So that's very important. But in case of soft contact lens, whenever central thickness increases, it's very helpful for the patient, especially handling issues. Yeah. So central thickness consideration, decay definitely, and another is pervaporation prevention. So thinner lens will definitely goes speedily pervaporation, but thicker lens it will protect that. Yeah. So fitting consideration, if lens is too thin, there may be excessive flexing. So thicker the lens, chances of flexion are less. If the lens is too thin but remains on the cornea, it move little. So a thicker the lens, movement is better. Yeah, a little bit. Design consideration minus lens series is always there. You have to understand lenses of the lower minus power are often made thicker and with a larger front optic zone diameter to improve handling. It's important point. While higher the power of the lens, may front optic zone diameter decreases because we want that thickness not to be so different from center to periphery. First important thing. So if we decrease the FOZD, then we can manage these things to reduce mid periphery thickness, because in minus lens center is thinner, mid periphery is thicker. So if we reduce the FOZD, then this problem can be a little bit managed, not completely solved. It's not impossible to solve. It's always there. Center is thinner and periphery is thicker. Yes. So central thickness for negatively powered soft contact lens ranges from uh, this is the range from icon. Yeah. So design consideration plus lens series. So basically in plus lens central thickness reduced by FOZD is reduction. So basically when you reduce the FOZD, what happens in plus lens is the thickness difference between center and periphery, because center is thicker, it's always there. But if you reduce FOZD, then central thickness difference, it's basically not central thickness difference, but the thickness difference between center and the periphery of the FOZD is reduced. Yes, and it will be helpful. So it will not be tolerated in most wearer except some with the small people. So that's why we cannot make a very small FOZD. So otherwise it will create glare, and I have already talked about in previous video. The only back vertex power determines the definitely central thickness. Central thickness for positively powered lens may be more than sometimes and less popular. That's why in case of high plus, we always see what do you call lenticular design, isn't it? Yeah, that's the reason. In high minus 2, if minus 14, 15, you will see lenticular design in soft contact lens. Yes. So water content, we know low, medium, high, but what do you call FTA, it is be less than 50 and greater than 50. So high water content, we have to be cautious because of vapor evaporation, and interaction with the uh, environmental world, and definitely for deposits and all these things. Yeah. So transmissibility, we have already talked about it. Yes, thicker the lens, lower the rate of oxygen passes and CO2 passes. So basically, CO2 is always pass speeder in contact lenses as compared to O2. I think you have to see that rate. I think CO2 will pass 21 times faster in soft contact lens and 7 times faster in RGB contact lens. I have exactly forgot that um, term, the number, but roughly like that. CO2 will pass very faster as compared to oxygen. So therefore, coronary respiration is best served with a thinner, high water content. However, causes the pervaporation. It's always there. So it's not good combination, thin and high water content. But yes, theoretically, it's better. But we have to think about handling. Thicker is better. High water content is always are not good. Yes, especially in case of dry eye because of pervaporation, and you will see clearly pervaporation staining in cornea. So pervaporation, what do you mean by that? If the lens is too thin, the corneal dehydration may result due to the bulk flow of water through the lens and instability in water flow. So basically, through the lens, water moves out in the environment. If worse with a high water content, definitely worse. That's why in dry eye condition, never prescribe high water, especially evaporated dry eye. Don't prescribe high water content contact lenses. So results in corneal dehydration from the water loses via the air. That's what evaporation is, and produce epithelial desiccation staining. So you will see a lot of evaporation staining in your life. So high water content lenses loses more water than the low water content. That's why I love silicon hydrogel, especially first generation silicon hydrogel for dry patients. Yes, lens shrinkage, which affects the total diameter and BOZ, and hence the effective fit. So whenever high water contact lens loses the water, then lens shrink. It will affect in total diameter and POZR of that particular contact lens, the high water contact lens. And because there is change in total diameter and BOZR, it will eventually leads to change in the fitting. Yes, yeah. So that's what we're talking. It's simple. Yes, thinner the lens, more oxygen will pass. Thicker the lens, less oxygen will pass. So higher the water content, more oxygen will pass. Lower the water content, less oxygen will pass. I have taken this picture from the first IFL, yes, model 2000 model. So back surface design, single curve, monocurve, simply not common. You will not see monocurve design. Bicurve design means often, just remember, often 0.8 to 1 mm flatter than BOZR. If your BOZR is 7, then it's 7.8, something like that. Yes, most common design because it performs satisfactory clinical. So basically you will see nowadays three back surface curves commonly, yeah, and or aspheric design. Back surface is not, there is two or three design curve, but aspheric curve. So blended multi surface means the junction between the two surfaces in back, they are blended. Simple. So front surface design is same. The diameter of the center optical zone of the lens, which means focusing of the ray in a retina. That's why we say optical. Its purpose is optical, not fitting itself. So usually defined as front optic zone diameter, usually 8 to 11 mm, and makes must be pupil size in photopic or isotopic into account. So they must cover people completely, the pupil. And RX may influence. The larger the RX, smaller the FOZD, smaller the RX, larger the FOZD. Yes, it's inverse. So commonly bicurve front surface is tended to be ignored since the front surface is not in contact with the cornea. So one thing, but front surface is definitely going to interact with the lid. That's important thing. But it's an important role to lens fit and on behavior eye and hence the comfort. If the two curve are not blended to junction of the two curve but not blended and they will interact with the upper lid, it will create sensation. Yes, so it's very important that front surface is behavioral thing, lens fitting things, because it will interact with the upper uh, paper. And another thing, the front surface is more prone to deposits. Yes, it's also important for the deposits, somewhat depending on the manufacturing processing. So soft lens edge designs and the thickness, I have already talked about it, and I'll definitely talk about it. Less consideration is given in detail of the edge design than RGB because of the size of the field. Basically, in RGB, lens edge design is more important than soft contact lens because soft contact lens is large and and it's basically larger the lens, lesser the chances it will interact with the uh, upper lid. Yes, The edge is already under the both lid. That's what I am talking about in soft contact lens. The edge has relatively little effect for the comfort, but RGB edge has really important effect for the comfort. So edge design may be limited by manufacturing issue, and edge thickness definitely, and too thicker, less more the discomfort. Too thin, it will create again discomfort and lens a tearing of the lenses whenever we handle it. Okay, so this is often considered to be more important. Yes, so it's very important that you understand that if edge thickness is too thick, then it will it will sure create discomfort because it will interact with the upper lid, but it's too thin, so it may lead to the tearing of the edge, when especially when you handle the lens, whenever you rub the lens. Yes, the chances of tearing of the edge is higher. Okay, fine. So material property, we have already talked about material property a lot. I think it's very important that we don't waste our time here. Yeah, it's significance of contact lens and RGB because of RGB is very important. There's DKBT, all the things that's important. Yes, so I don't go here a lot time. So with the final discussion on everything. So let's summarize it. So central thickness of the lens at the geometrical center affects basically lens weight, optical performance. At the same time, oxygen transmissibility is most important. Overall diameter, it means it defines edge to edge measurement of the basically diameter edge to edge from the center. Determines lens coverage the cornea, sclera, impact on comfort and stability, and definitely where it's very important in case of society light. When you were talking about society light, yes, front optic zone diameter determines the central optical zone of the front. So just important understand optical zone. Yes, so control the usable optical area, that's very important. Okay, front optical zone diameter means usually optical area of the front surface, affect visual acuity and the aberration. Back optic zone diameter, definitely optical zone and the posterior surface, so determines the area of the fit on the contact lens and tear distribution. Yes, back optic zone radius, so basically it's base curve. Yeah, so basically match with the cornea for proper fit and affect the lens movement and comfort and tear actions. Yes, lens design, shape and profile of the lens design, round, trap, knife. Most important is comfort, lens design. Yes, and lead interaction definitely, and tear actions definitely is now we know edge lift and edge clearance. So degree of separation between lens edge and the corneal surface is edge clearance. So edge lift is another term. Yes, control tear actions and lens movement, and too much of edge lift will create discomfort. Basically too much of edge lift means flat fitting too, and too little or lift, poor tear actions. That's very important. That's why we are talking about 60 to 80, yes, micrometer in case of corneal lens. Just remember, in case of corneal lens, peripheral curve system, additional curve outside of the optical zones. What it does is it's a smooth lens transmission to periphery. Real important work is improve fit and comfort. That's important. Periphery curve, importance of periphery curve is in fitting and comfort. Sagittal depth, we have talked a lot, we have taken a lot of time. So vertical depth of the lens from the chord of the back surface, what it does, it influences the lens vault and overall cornea and fitting stability and TRX sense reservoir, especially in uh, scleral lens. We have to calculate sagittal depth. And lens material decay, oxygen permeability of the lens, higher the decay improves the oxygen transmission. But in case of RGB, higher the decay means lens rigidity is less. So tint and marking is very important. Light tint and engraving mark for handling and assistant lens insertion, orientation and fitting. These are important. We have not covered a lot, but that's good. So let's move further. That is our reference. I've taken a lot of pictures from this book. Good book. Yes, Efron, another good book. I'm a fan of this book for practical fitting purposes. Yeah, definitely great book is Phillips, also great book. The four books, they are very, very good. So I suggest all the books. Okay. So I think that's it. Bistan, choose.